All right, we are here again and we are ready for another math lesson. And this is going to be 3.6. So if you will turn in your book to page 81, I wanted to it's actually a fairly short lesson. Most of what you see on those pages are examples, which is good because we're going to need several examples in here. So anyway, I wanted to help you with this because it's not hard, but I didn't want you to just have to read it yourself and figure it out. So let's look at page 81. We're going to read through this and talk about these examples right quick, okay? All right, so it's time now to consider a very important mathematical convention. Maddie, I need you to be quiet, okay? The order of operations. Conventions, unlike properties, are agreed upon protocols or rules that aid us in communication. Much as we could use different grammar rules, and we do in other languages, we could use different conventions in math. Math rules, however, are a little bit more unforgiving than grammar rules. While people can often still guess their way through a poorly punctuated sentence, using the wrong convention in math will result in a totally different answer. So, order of operations. Now, what happens when we need to perform more than one operation on a group of numbers? How do we know which operation to perform first? Consider 4 plus 12 divided by 2. What does this equal? Do we divide 12 by 2 and then add 4? In which case we would get 10. Or do we add the 4 and the 12 and then divide the sum, which is 16, by 2? In which case we would get 8. To avoid this vagueness, we follow an agreed upon order. This convention is known as the order of operations, and it's very important to memorize. Now I want to stop right there for a second, because if you have that equation, somebody over here might say, well, I want to do the division first. Okay, and someone over here says, well, I want to do the addition first. Okay, we're going to get two different answers. Well, just like those the grammar and things that we use, you can get by with that, but you couldn't get by with two different math answers. So that's why we have to have the same rule. That's why they call it a convention. What, baby? Do this. All right. Yes, you may. All right, so let's look on page 82. This is the order of operations. And I believe on your worksheet for today, on the very back, on the last thing, it's going to tell you to write this down in your notebook. And it really is, if you write anything down, I would write this down on a note card, print it out, make it fancy, schmancy, whatever. Quilt it in a quilt if you want to. Whatever you want to do. All right, so here it is. So first thing, solve anything within parentheses first using the following order, which is the same order we'll follow outside parentheses too. Okay, solve exponents and roots from left to right. Multiply, and I know you don't really know those yet. Multiply or divide from left to right. Add or subtract from left to right. Next, solve exponents and roots from left to right. Now multiply or divide left from right. Lastly, add or subtract left from right. Now number one, where it has A, B, and C, that means inside the parentheses if you have more operations inside parentheses. You do anything inside those first in that order. And then outside the parentheses, the order is the same. Okay, so now, if we take 4 plus 12 plus 2, all right, or I'm sorry, divided by 2, we would do the division first, and then the addition giving us 10. Below are a few other examples of how this convention works. Now what I'm going to do is I'm going to put it on the screen so you don't have to look at it on the paper. And I'm going to work it little bit by little bit. And I'm going to also show you something else. Frankly, I don't know if what I'm going to show you is going to be, I'm guessing they're not teaching you this, but it's what I've taught my kids to help them remember the order of operations. Now, one of my daughters who went to college told me that when she gets to college, it's different. It changes. But it will help you through high school. So I'm going to give that to you and I'm going to help you. So we're going to go ahead and go to the screen and we're going to be working these examples on the screen. Okay, so here you see this really weird word. PEMDAS, we call it. And this helps you remember the order of operations. Now I didn't write the words out because it's too hard for me to write with this because I have to use the mouse on my computer. But this stands, you can write it out if you want to. This stands for parentheses, exponents, multiplication, division, addition, subtraction. PEMDAS. So if you want to remember that, you can write that down. I would put that on a note card. It helps you remember what to do first. Parentheses, exponents. And this is written on the top of page 82 in your book. It just isn't written like this, but it's parentheses, exponents, multiplication, division, addition, subtraction. Okay, that might help you remember. Like I said, my daughter told me in college this is not right, but it has helped every one of my kids to get through high school math and junior high math. All right, so I'm going to go ahead and help you walk through these examples. So the first thing is this example on page 82, okay, says we're going to solve 36 divided by 3 plus 3 times 3 minus 10, what is that, divided by 5. Okay, that's kind of crudely written, but that's the way we're going to do it. Okay, so first of all, we're going to look and see that there are no parentheses. All right, so that means that we have to work the division or multiplication in the order it appears as left to right, because there are no parentheses, there are no exponents. You haven't learned those just yet, I don't believe. Okay, so these two are done. So we start with multiplication and division. Well, if there are no parentheses and we're just doing it, that means we start from here and we go this way, just like we would do normally. All right, so the first thing we're going to do is we're going to say, all right, so 36 divided by 3. This is a division. All right, so we're going to bring that down. We know that's 12. Okay, now we're going to go ahead and bring this down because we're not doing this yet, which means we have to leave it exactly the same. All right, now this is times, so we're just bringing everything down. I know we're doing multiplication, but we're just doing one step at a time. Minus 10, and then divided by 5. Okay, I'm just letting you see that we're just doing one step at a time. This was the first thing we did because it's multiplication division. All right, so the next thing we're going to come back and start this way. Remember, multiplication and division. All right, we can't do this yet because that comes later, and we still have a multiplication right here to do. So what we're going to do is we're going to bring this down. 12, and then plus, all right, what's 3 times 3? 9. And then the rest of this we're going to write down here, minus 10 divided by 5. All right. All right, see, we still have addition, subtraction, and we have a division here left. So remember, we have to do division before we can go to addition and subtraction. So we're going to bring this down, 12. I know this seems redundant, but it really is helpful. All right, so minus, what is 10 divided by 5? 2. All right, look what we're left with. Addition and subtraction, which are the last two, which means we need to start over here. Remember, all the way from the left and work our way right. So 12, pardon me, 12 plus 9 is 21. And bring this down, minus 2 equals, what does that equal? 19. Ta-da! There we are. That's how you would work the order of operations. Alrighty then, let me see if I can cut this out so we can do this next one here. I'm not very good at this. It's kind of weird. Alrighty then, I want to leave that up there. Okay, so let's look at the next one, the next example, and it has some parentheses. Alright, so we're going to go 36 divided by, you can work this on paper if you want to, see if you get it right. Of course, it's in your book, but you don't have to look at it. 3 plus 3 times 3, close parentheses, minus 10 divided by 5. Now in this problem, look what we have, parentheses. So that means we have to do the parentheses first. There are no exponents, so you don't have to worry about that for a little while. We're not going to get to exponents for several more chapters, I don't think. So right now, parentheses. But remember what it tells us at the top of page 82, that inside the parentheses, we also have to follow PEMDAS. All right, so there's no parentheses. Well, I mean, there are, but none in the parentheses. No exponents, so we're going to go here. Multiplication, division. We have to start left to right. We have addition and we have multiplication. So we have to do multiplication first. So we're going to write everything down. 36 divided by, all right, we're going to say 3 plus 3. Well, I'm not going to say 3 plus 3. We're going to say, because this is 9, because we have to multiply these. Minus 10 divided by 5. Okay, still have parentheses, and it just has one operation in it, so we're just going to do that. So now we have 36 divided by, what is this, 12, minus 10 divided by 5. Okay, now we've got two divisions and a subtraction. So we have to do these divisions first. This is going to be 3. And then minus, and then this is 2, right? So we're left with 1. Makes sense? I kind of cheated here. I should have made one more step, but just because of time's sake, I didn't. Does that make sense there? All right, that's our order of operations. Remember what I said? You might want to write that down, and I'd put the words with it unless you think you can remember that. All right, look at the top of page 83. It says combining the conventions using parentheses for multiplication. Remember from section 3.3 that the dot and putting a number next to the outside of a parentheses are both ways of representing multiplication. So here's different ways. You can say 2 times 3 this way with the x, which as you get a little bit older and you get into algebra and pre-algebra, you won't be using the x because a lot of times this means something else, which is a bummer, but that's okay. Or you can use a dot. This is the best way. Or another way is to use parentheses. Okay, when a number is right next to the parentheses like this, that just means multiplication. Okay, so can you see now why putting a number next to a parentheses is helpful? It comes in handy when we need to use parentheses to show which numbers need to be added first. It saves a step to write, and then there gives you an example on that on the top of 83. 2 times 4 plus 6 minus 8. Instead of writing 2 times with an x, 4 plus 6 minus 8, although they both mean the same thing. It's just easier to do it this way. So this is a good way to do it. So anyway, all right, so as you review the order of operations and use parentheses, keep in mind that conventions are agreed upon ways of expression, part of the language used in mathematics to communicate clearly. All right, if you will, I'm going to go back to the screen. All right, so let's look at worksheet 3.6. It's going to be pretty easy. Number 1 is learning the language. Use the conventions and properties you've learned to help you solve these problems. Don't forget that a number next to a parentheses means multiplication, like 4 times 3 means the same thing as 4 times 3. Okay, so basically you're just going to work those problems A through E using PEMDAS. All right, in 2, 3, let's see, 4. I'm pretty sure most of the rest of this you can write yourself. And you can finish yourself. If you need any help, let me know. I'm not going to grade this page, but I do want to see it to make sure you got it. So if you didn't understand something, let me know and I'll explain it a little bit further. That's all for today.